So for this question, we have a table that has some times and velocities that correspond with each of those times. For part A, they ask you to justify why there must be at least one time t for t is between 0.3 and 2.8, at which v prime of p equals 0 meters per hour per hour. First of all, I think most of you have taken physics, and you probably are more comfortable seeing this written as 0 meters per hour squared. Same exact thing, just another way to write it. You can write it either way if you're asked to write units. On the AP test, they will accept both answers. So if you see a problem like this, I want you to recognize that it usually is one of three things. So the most common are either the mean value theorem, the intermediate value theorem, or a little bit less common but not unheard of, the extreme value theorem. So if they ask you to justify why there must be at least one time t, or they ask why is there at least one time t, something along those lines, it's usually a sign that you're using one of those theorems. In this case, we are looking at the derivative of v, which means that we're going to be using the mean value theorem. That's like a little trick to use if you have the derivative of your function. That often is a sign that you're looking for the mean value theorem. So mostly any theorem that you have in calculus, not all of them, but most of them, you are going to check and make sure the function is continuous. You usually can't use any of the major theorems without continuity. In this case, we know that it is continuous because they tell us it is differentiable. So I'm going to start by saying Vp of t is continuous. And you can even say because it is differentiable. So that's the first thing you should always check. The second thing I'm going to do is I'm actually going to use the mean value theorem. And the mean value theorem says that if you find the average rate of change over an interval, the derivative at that somewhere in that interval is going to be equal to the average rate of change. So the average rate of change over that interval is going to be Vp of 2.8 minus Vp of 0.3 over 2.8 minus 0.3. You're going to notice that the velocity at 2.8 and 0.3 are both 55, so that actually is equal to 0, which is a good sign. That's what we want because they're asking us to show why the acceleration, the derivative velocity, equals 0. So we've shown that it's continuous. We've mentioned that. We've shown that the mean value theorem applies because the average rate of change is equal to 0. Now we can just write a little sentence. I actually usually like to rewrite pretty much the exact statement they give you there on the AP tests. That's really the best way to make sure you get everything that you need. So I'm always going to start by mentioning the mean value theorem. Don't forget to mention the theorem that you're actually using. So then, like I said, I'm just going to rewrite the question that they had. So I get this. In order to get full credit on this problem, you need to have shown this step right here, where you show that you get 0 for the average rate of change, and you need to justify your answer using the mean value theorem. Make sure that you mention the theorem that you use by name. They actually didn't give a point for continuity here, but in the past they have, so make sure that you also check that. That's an important condition for using the mean value theorem. So part 2 of this question asks you to find a trapezoidal sum. So if you recall, The trapezoidal sum means that you're going to be finding areas of a bunch of trapezoids and then adding them together. The area of a trapezoid, if you recall, is 1/2 times base 1 plus base 2 times height. So in the context of the trapezoidal sum in calculus, the height is going to be our delta x, in this case it's delta t, which is going to be the distance between our t values. Base 1 and base 2 are going to be our y values, which in this case is actually going to be our v values. There is a formula for this, but if you understand this idea of a trapezoid area, that might be easier for you. If not, you are welcome just to use the formula and substitute numbers in. So I'm going to write this out, and it is very important that you make sure to show this next step. Also, I'm going to put approximately equal to. You do need to show work to get full credit. If you just write an answer, that's generally not going to be sufficient. So I have 3 intervals that they give me. My first interval is from 0 to 0.3. So my height, also called my delta t, is going to be 0.3. It's the distance between those two t values. My first base is 0, my second base is 55. My next little trapezoid is between 0.3 and 1.7, those ones right here. So in that case, my height, also known as my delta t, is 1.4. You do 1.7 minus 0.3. My 2 bases are 55 and negative 29. The final interval is 1.7 to 2.8. So in that case, my height is 2.8 minus 1.7, which gives me 1.1. My 2 bases are 55 and negative 29 again. Actually, if you leave the answer like this, you will get full credit. I would recommend, if they ask you for units, you just write this and then you write meters would be the units here, because if you take the integral of a velocity, your unit is going to be a distance. But if you work this out, you can just stick it in your calculator, you should get 40.25. And actually, this is a 1-point question. You just get 1 point for getting that answer. So for part C, I have a function, I have a graph of that function, and I know that the full integral from -6 to 5 is 7. I have a graph that only goes from -2 to 5. I need to figure out the value of that missing portion that's not on the graph between -6 and -2. So the first thing I'm going to do for this problem is write a relationship between the two things that they actually mention in that part of the problem. The first thing that they mention was the integral from -6 to +5 of f of x. The second thing they mention is the integral from -6 to -2. So I know that the integral from -6 to 5 is the sum of the integral of -6 to -2 plus the integral from -2 to +5. So now I'm going to look at what I actually have and what I need. By the way, if you get this step right here, this is worth a point. So that's worth 1. So I know, based on them telling me, that this integral right here is equal to 7. That's a good start. I am trying to find the integral from -6 to -2. That's going to be my question mark. The last thing, the integral from -2 to 5, I don't know, but I can find it because I have a graph. And so I'm going to do that right now. So I can find this integral either by using integration, or I can do it by finding areas under that curve. So my first part of that integral that I have is from -2 to -1. I have a triangle. I know that that triangle has a base of 1, a height of 1. If I use 1/2 base times height, I get that that triangle has an area of 1/2. That's going to be from -2 to -1. Second thing I know is from -1 to 0. I have another similar triangle that also has an area of 1/2. However, because that's under the x-axis, I'm going to make that one negative. The next thing that I have is this line right here. There are two ways that you can do that next part. You can write it as a sum of two triangles, or you can actually write it as an integral and take the antiderivative. So I think both methods are about the equal, they're about the same amount of work. If you were to do it using geometry, you would find out that this little triangle down here has an area of -1/4. You would do 1/2 base times height. The base is 1/2, the height is 1, and because it's underneath the x-axis, it's negative. If you were to find the area of this triangle, you would do 1/2 times the base, which is 1.5, times the height, which is 3, which would give you 9/4. And then if you subtract 9/4 minus 1/4, you would get 8/4, which is 2. The other way to do this is you can figure out that this is a line that has the equation y equals 2x minus 1. If you find the integral from 0 to 2 of 2x minus 1, you will get the same answer. You're going to get 2 whichever way that you do it. So it's up to you how you want to do that. So for the next part, from 2 to 5, that one's a little bit more challenging. What I'm going to do is I'm actually going to think about what the area, I need to figure out what the area down here is. I know that that curve is a quarter circle. I know how to find the area of a quarter circle. Finding the area underneath a quarter circle is a little bit more challenging, but what I can do is I can actually find the area of this whole entire square, and then I could subtract out the area of that circle. So the area of that whole square is going to be 9. If I subtract the area of this circle right here, I'm just going to use pi r squared. The r, notice, is 3, so it's going to be pi times r squared. Then I'm going to divide it by 4 because it's a quarter circle. So in the end, you should find that when you combine everything, you get 11 minus 9 pi over 4. This is the answer to the integral from -2 to 5. I'm not done with the problem yet, but that's my next part. And that one will give you a point if you get that. So for the rest of this problem, I'm actually just going to take the equation that I had up there. I'm going to rewrite it as 7 equals the integral that I'm actually looking for right here, plus 11 minus 9 pi over 4. So the answer to the problem, I just get by subtracting that 11 minus 9 pi over 4. My final answer is 9 pi over 4 minus 4. And if you get that, you get the third point for the problem. So for part C, we are evaluating this integral right here. First thing I am going to do with this integral is split it up into 2. be really careful with that plus 4. A lot of people try to pull that out of the integral and just keep it as a constant, but we actually do need to integrate. So you can pull that out front if you want to, but you still are going to have to integrate that dx there, which would give you an x. So let's start with what we have on the left. So that 2 is going to come out front. The integral of f prime of x, by the fundamental theorem of calculus, it's actually just going to be f of x. And that's going to be evaluated between 3 and 5. Then the next integral, 4 dx, is just going to be 4x, also evaluated from 3 to 5. So in order to evaluate this, I'm just going to substitute some stuff in. I get 2 times f of 5 minus 2 times f of 3 plus 4 times 5 minus 4 times 3. So you can look at the graph and notice that f of 5 is equal to 0. They actually told us that the point 3 minus radical 5 is on the line, so, or is on the graph, so I'm going to just plug that in for f of 3. And then I get plus 20 times minus 12. So I end up getting negative 6 plus 2 radical 5 plus 8, which gives me 2 plus 2 radical 5, and that's actually my answer for that problem. So just a note on this problem, you are perfectly welcome to stop right here. You don't need to simplify it out. If you get this far, that actually is worth 1 point. And also, taking the antiderivatives here, using the fundamental theorem of calculus and getting the correct antiderivative of 4 dx is also going to be worth 1 point. So for part E, we are finding the absolute maximum value of g on the interval. Before we start this problem, I want to point out that the absolute or relative maximum or minimum are always going to be a y value. They're not going to be an x value, they're not going to be a point, they're actually just going to be a y value. So the first thing that we know is that the function g is given by this integral of f. What that means is that g prime is going to be equal to f of x. That's going to help us in just a minute. By the way, if you just write this, that's worth a point. So in order to find an absolute maximum or minimum actually, you're going to have to check several things. You're going to have to check endpoints on the graph, and you're also going to have to check relative maximum values. So for the endpoints, you can see based on the interval that I have an endpoint at -2 and my other endpoint is at +5. So my relative maximum value is going to be where g prime changes from positive to negative. And that actually is, if you remember that g prime equals f, this point right here, I have a relative max at x equals -1. By the way, there's a relative min 1/2. We don't need to worry about that because we're looking for the maximum. So we're just going to be looking at x equals -1. By the way, you can get another point for this problem just by checking if there is a relative max at x equals -1. So the third point on this problem takes a little bit more work than the first two. We need to figure out our y values at all three of those, these possibilities. The absolute max is going to be the y value that's the highest. And I should clarify, by y value, I don't mean the y value based on the graph. I mean the y value based on the g function. So I'm actually going to find these values using a table. So let's start with x equals -2. So g of -2 is going to be based on this integral. If you remember the rules of integrals, if you go from a value to itself, the answer for that one is 0. This actually, 0 doesn't necessarily mean it's not an absolute max. For all we know, -1 and 5 could be negative, in which case this one actually would be the absolute maximum. So we don't need to discount it right away. So then for g of -1, that is going to be the integral from -2 to -1 of f. If you look at your graph, that is this actually going to be this triangle here. And so that one is 1/2. So the last thing I need to look at is g of 5. Thankfully, we've actually already found the value of this integral from -2 to 5. In part C, we found that it was 11 minus 9 pi over 4. I would recommend just using your calculator to evaluate that. You will find, though, that that is bigger than 1/2. So that actually is going to be my absolute maximum. In order to get the last point, you do need to get the correct answer for that. For the part where it says to justify your answer, if you showed all of the supporting work that I just showed here, that is enough justification to get the point. So for part F of this problem, we are finding a limit, and I'm going to find this limit using substitution. Generally, the two ways that you're going to be evaluating limits on the AP test are either going to be by substituting in values or by using L'Hopital's rule and then substituting in. So in this case, we end up getting that we have 10 minus 3 times f prime of 1. If you look at this value right here, we have a slope of 2. That is going to be my f prime. Keep in mind that the derivative of a line is actually going to be the slope of that line. And we know that f of 1 is at 1. You can see that on the graph. Arctan of 1 is pi over 4. Actually, if tangents and arctangents like really bother you, especially for something where you don't have a calculator, you are free to write it like this. This right here will give you the full and complete point for this problem. It's only worth 1 point. You do not need to go further. However, if you would like to go further, you will get 4 over 1 minus pi over 4, and that's the final answer for that one. So like I said, this one's just worth 1 point. You get that point just by getting the answer. So for part G, this question is very tricky. You have to really read it carefully. They give you what G is, and they ask you, is the rate of change of G increasing or decreasing at t equals 1? So the rate of change of G is G prime. What a lot of people like to do is they just look to see if G prime is positive or negative. That actually is not quite right. To figure out if G prime is increasing or decreasing, you are going to look at the sign of G double prime. So if G double prime is positive, that means that G prime is increasing. If it's negative, that means that G prime is decreasing. So if you miss reading the words rate of change here, it's very easy to make a mistake on that. So just keep that in mind. Just read these types of problems really carefully. Okay, so what we're going to do for this one is figure out what is g double prime of 1. That's what we need to find in order to figure out if the rate of change of g is increasing or decreasing. So first of all, we know that g prime of x is equal to f of x. That means that g double prime of x is going to be equal to f prime of x, the derivative of f. And so then what we're going to do is we're going to look at the derivative at f equals 1, and I think I actually just mentioned this in the last problem. F prime of 1 is going to be the slope of the tangent line at 1. Since it's just a line, it's going to be the slope of that line, which is going to be 2. So for this one, because our f prime of 1 is positive, that means that the rate of change of g is increasing at that point. And this type of explanation is sufficient. You do need to mention the second derivative and that it's increasing. It'd be nice if you showed all of the supporting work that I just have right here. This one would be worth 1 point, by the way.